everyone. Can you hear me?
Yes, we can.
Okay, let me share my screen. All right. So hi, everyone. My name is Siyi. I am currently a product manager at EVConnect, which is a EV charging software startup. Prior to that, I was a product manager at Tesla, focusing on a product called Opticaster, which is Tesla's energy AI software. You can think of it as a autopilot, but instead of deploying in car chips, we're putting into big, large batteries on the grid. So today I'm very excited to share my journey as a product manager and kind of just share with you all on my learnings on how to build AI products in the clean energy space. And also, I think the timing is really perfect today for those of you who are in the US. President Biden has a really ambitious goal for mitigating climate change. And for those of us who are in energy, there's a lot of things we can do. So I'm really stoked about it. Before I talk, sorry I have to do another survey just to get a sense of kind of the audience here. Just type in the chat box if you are in energy and climate and environment sector. Type 2 if you're in data or interested in data, ML, AI, or you're the unicorn like me, type 3. Oh, cool. Thanks for the great response. I think we have definitely a very mixed crowd here. I'm very excited. And for those of you who are in machine learning and really the industry experts out there, sorry, I'm by no means a AI machine learning expert, but I do enjoy working extensively with data in the past few years. And for those of you who are in energy and climate, I think you will find my career path very relatable. So a little bit about me. I'm from Shanghai, China, came to the US for college, got my bachelor's degree in geology and civil environmental engineering at MIT. At that time, I was a very staunch environmental engineer. I helped analyze like long-term impacts of climate change on air pollution and human mortality using atmospheric ensemble modeling, technical economic analyses, and also cell phone mobility data. By leveraging those big data, I realized that millions of people will be literally dying from climate change if we don't act now. So that was a really pivotal moment of me. And I realized I didn't just want to just study the aftermath of climate change, but rather try to solve the problem. So at that time, renewable energy seems to be a no-brainer for me as a next step. So I went to Stanford to study renewable engineering, and then pivoted myself into the clean energy industry. I landed an internship at Tesla as a associate product manager, and then stayed with the team and found a full-time role working with the energy AI product. And after 3 amazing years, I decided to give myself a challenge by throwing into a very cool EV charging startup. That being said, even though I have left Tesla, I've always been a huge fan of Tesla and a proud shareholder as well. So today I'll be mainly talking about my PM journey and my Tesla experience. And just to kind of set things straight, opinions today are all on my own and not the views of Tesla. Okay, so here's an agenda. First, I don't know why there's a little stroke there, but first of all, I would like to cover some fundamentals on the power grid so that those of you who are not in energy could understand and appreciate the role of Tesla energy products and AI software in the grid system as a whole. Is there any way to remove this? But if you guys are okay,
I'm looking at removing it. I think someone
yeah.
vote and we remove.
Oh, okay, cool. Yeah. First of all, Power Grid 101. The grid as of today, as you can see, is a very much centralized one-way system. Power plants pump energy into the grid, the electricity carries through the transmission and distribution lines, and then get consumed by homes and businesses. So the idea behind it is very simple but profound. Supply equals demand at all times. So if you don't balance the supply and demand, well, you've got a big problem here. The grid frequency will deviate and will result in brownouts and blackouts, causing big damages to the economy and people's well-being. So matching this energy supply and demand used to be a pretty manageable thing to do, since everything is super centralized and one directional. But with the grid is actually changing very rapidly. With the rise of solar and wind, the grid now is flooded with intermittent renewable generations at all levels, and the power lines are really not built for this modern grid infrastructure. It was built ages ago, and it gets very old and fragile. The energy consumption patterns are also evolving. People are now plugging chargers into their EVs on a regular basis. The home appliances are getting more efficient. People are using their machinery more differently than before. So we have a big problem here. How do you address this increasing mismatch of supply and demand problem, especially when the grid gets so dynamic and complex? So the answer is we need to deploy more flexible energy resources and manage them intelligently. So what I mean by flexible energy resources is any energy assets that are able to ramp up and down in terms of its power production and consumption in response to different scenarios. So that's why battery storage, energy storage systems become a critical piece in this energy transition puzzle. It basically charges when there is oversupply of power, discharging when there's over demand, and then it simply absorbs that supply demand imbalance and stabilizes the grid. Unfortunately, actually dispatching those flexible energy resources like batteries are pretty tricky. First of all, the renewable generation is super unpredictable. It's by nature cannot be controlled. The wind doesn't blow all the time. You don't have sun 24/7. And also the demand is really hard to predict. And also there's this energy storage equipment is also kind of an early tech industry with very limited cycles, efficiency, power rating, energy capacities. Also, there is a wide range of use cases that's super complicated and region specific and subject to changing regulations. So we are quickly reaching a point where human cannot simply manage this rapidly evolving monolithic grid infrastructure with conventional methods. So that's really a prime time now for the energy industry to embrace AI adoption. So I know we're talking about AI, machine learning all the time as such a buzzword, but what does it really mean for the clean energy industry? So here I wanted to actually highlight 4 major applications we see in clean tech today: AI for energy consumption, AI for virtual power plant, AI for electricity trading, and also AI for operation and maintenance. Let me unpack what those means. So let's start with energy consumption. So what we'll be talking about is 3 different categories: savings, resiliency, and sustainability. So let's delve into savings. What I meant by savings is actually just utility bill savings. So for many commercial and residential customers in the US and many parts of the world, we have a time of use rate plan in which you are charging actually a higher dollar per kilowatt price during certain periods. And you're also subjected to what we call a demand charge. So that will be based on the highest peak power you draw from the grid each billing cycle. And often you don't really know when that peak demand is going to happen. So with an accurate load forecast, the battery will be able to shift your consumption to a cheaper time period and predict when those demand peak will going to happen and shape your peak accordingly. So that way you can save a lot of money by doing time of use, energy shifting, and demand charge management. And this is by far the earliest and probably the most dominant AI application we see for behind the meter batteries in the energy space to date. And you'll actually see a lot of AI-powered algorithms and energy storage companies out there that are already working on this. So that's pretty pervasive. And the second piece that really important in terms of energy consumption is that for end users, we care a lot about sustainability. People want to consume as much as clean energy from their rooftop solar as possible. And with solar generation forecasts, the battery could prepare the conditions in a way that you could maximize your usage of solar production the next day. And you might ask, if you don't have solar, what you can do to kind of achieve your sustainability goal. And actually, the answer is yes, you can. You can still go green. That's because the power from the grid is actually not 100% clean. It's a big mix of coals, natural gas, renewables, and the energy mix is also constantly changing. As you can see, it's depending on the time of the day and also the month of the year. So with this real-time greenhouse gas emission signals from your grid and also forecast of when those cleaner periods is going to happen, AI can optimize your battery so that you could reduce your carbon footprint by using more energy when the grid is cleaner and using less when it's dirtier. And the third piece for energy consumption is resiliency. People losing power all the time, no matter where you go in this world. With climate change, you have more extreme weather events such as wildfires, hurricanes, and also they're also becoming a lot more common. So instead of passively reacting those outages, what AI can do is actually just prepare for those power outages events, knowing when it's going to happen, how long it's going to last, and then like fully charge the battery ahead of the time without any human intervention. Tesla Stormwatch is a perfect example here. Thousands of batteries are activated during the last California public power shutoff seasons so that the batteries can keep people's lights on when the grid is down. Just imagine how happy and how secure you are when you could put your hot food on the plate and take hot showers when there is a major power outage. So yeah, that's the three main pillars for AI for energy consumption. And the second major application in clean energy I see today is AI for virtual power plants. So previously, we're talking about AI and the benefits of one single energy consumer. What about hundreds and thousands of them? Can we aggregate all these energy assets just deployed at homes and businesses and provide some values to the grid? The answer is yes, we can do that through virtual power plant. Virtual power plant, by definition, is a network of decentralized grid interactive assets, such as energy generation units. You have wind, solar, you also have batteries, EVs, smart appliances, flexible loads, etc. So over the years, Tesla actually has pioneered many virtual power plants in many parts of the world. In Vermont, US, for example, thousands of power walls are dispatched to reduce the system level peak of the New England region. And also we have a virtual power plant in South Australia that helps the grid to stabilize its grid frequency. So the virtual power plant is not only doing good to the grid system, usually it comes as a form of program that people could participate and having some financial compensation. So while you are helping the grid to prevent grid outages, saving millions of dollars for the utilities, you're also earning some money by participating in it. So it's a truly win-win situation. But operating all these assets in one virtual power plant is not an easy feat. The biggest challenge right now is how do we balance kind of the global need of the grid operator and also the local needs for those consumers. For example, how do you make sure people are saving money on their bills, consuming as much as solar as they can, have enough battery energy for backup, while making sure the whole virtual power plant in aggregate could discharge for example, 50 megawatt of power for a certain period when the grid is stressed. So with the advent of artificial intelligence and also edge computing deployed in Tesla energy storage systems, we can tackle this problem pretty confidently. And there is a really brilliant tech talk done by previous colleagues on Tesla virtual power plant. I highly recommend it if you want to get into the technical details. And the third application is electricity trading. So similar to algorithm trading you see in the stock market today, AI can also help automate trading in energy market using fast responding physical assets such as batteries. It could significantly augment the energy traders with insights onto various bidding strategies and inform very high value decision making in complex trading scenarios. So with forecasts on market price, renewable generations, weather information, real-time grid congestion level, all the past power exchange transaction histories, AI continuously generate optimized bids that yields the highest return for the assets. So what you see here is Autobidder, Tesla Autobidder, which is a real-time trading and control platform. It operates on world's largest battery site in Australia, which is equivalent to about 2,500 Teslas cars, and it is actively participating in various markets and services. So the capital cost of this big battery deployment by using Autobidder is recovered in just 2 years. So the value is huge. And also there's an external value as well. It saves South Australian customer tens of millions of dollars over the first year of operation, preventing the grid from going down for millions of customers. And previously, all the three applications I was talking about is mainly driven by energy storage deployment, which is the primary focus I have at Tesla. But I do want to point out that AI extends beyond just batteries. In this age of digitization, you see millions of IoT devices on the network generating huge amounts of data that are poorly managed and severely underutilized. So one emerging use case for such data is that you could do that for operation and maintenance. You can create powerful data management and predictive analytic tools to detect and isolate faults, identify grid abnormal activities, and predict when an outage will likely to happen, and optimize your maintenance schedules to save money and also improve customer experience. It could apply to power lines, relays, substations, but also a lot of distributed devices like thermostat and also like charging stations. In fact, like at my current company, we're working on artificial intelligence to help the station operators to recognize when those stations are going to fail, so customers don't pull their EV cars into the station and realize they're going down. So we'll be able to fix those station uptime in a really quick manner than before. And also, like, this is computer vision, which is a lot of people's favorite topic. You could deploy drones to detect problems instead of sending trucks of electricians to diagnose issues on the grid as well. So as you can see, there are so many ways for AI to disrupt the energy industry and accelerate grid decarbonization. So it is really a truly exciting time to be an AI product manager in clean tech. All right, so with that, I wanted to share what I learned from my product manager experience at Tesla. First of all, data is messy. Energy data is really, really messy. We all know by now, data in this digital age is messy by default, but when I first came to Tesla as a product manager, I was caught off guard when I started working with real world energy data. The energy data right now is ubiquitous and dynamic and incredibly disorganized. For example, every utility has its own way of designing, publishing, updating rate plans. Your energy consumption and generations are also measured at a sub-minute level using smart meters, which could drastically vary in terms of quality. And also for many customers out there, they don't even have smart meters. We have no clue on their day-to-day energy patterns to train any models on. And at the same time, there are hundreds of like state, federal tax incentives, rebate programs that's buried in hundreds of documents with very specific requirements. We also have energy powered transaction activities and prices that are very regional specific, market specific, with various interfaces and latencies. So the problem is there isn't any universal data sharing or standardization on energy data. We see a lot of initiatives in the industry from both public and private sectors trying to consolidate how we use, communicate, interpret energy data. But they're oftentimes still like inaccurate, too loose, that opens for so many different interpretations, or too restrictive to be adopted by major industry players. So how do you deal with that mess? So as AI product manager, I think we really need to see beyond the chaos by focusing on the part of the data set that truly matters to the customer and the business objectives. It is really easy to get distracted and overwhelmed by all the edge cases and lose sight of the customer perspective. I think we should really ask yourself, is this piece of data really needed? How much impact would the customer have? And would customer even notice the difference? The second piece is trying to identify the most important issues with the data proactively early in the process. I never think data cleaning is an engineer's job. In fact, I think as product manager, you need to be fully aware of the advantages and deficiency of the data, because it not only hurts performance when you're building out a model, but will result tons of issues in production and deployment. So I think we should really be comfortable delving into example data sets, inspecting them ourselves, providing guidance and context on data cleaning and handling while working with the engineering team. So that's lesson 1. Lesson 2, understand your customer and all the stakeholders around them. At Tesla, I worked at the B2B energy space, so almost certainly I deal with multiple stakeholders throughout the life cycle of any project. For example, we've got channel partners who have sourced the deal and have a direct relationship with the end customer, but Tesla really don't have any knowledge of what this end customer is. And we also have project financier. So they own, so a project could be owned by a bank that only cares about the payback and the tax credits. And you also got the corporate leadership that's keen on understanding not just the bill savings, but also sustainability objectives. And you also got utilities. They are the people inspect, test, and approve the project, and so that your project actually could come online and operate. And you also have incentive administrator that requires a lot of performance and compliance reporting. And you also have people in the field who just needs to know if the system is doing the right thing. So majority of my time spending as a PM is actually not building the cutting edge algorithms with high speed or accuracy with the engineers, but a lot of times it's just like addressing, balancing the needs of various stakeholders. So as an AI PM, you really need to be aware of the complicated requests and trade-offs among your stakeholders and craft your message in a way that the value of your AI products is understood by various stakeholders. And that comes to lesson 3, focusing on the value proposition. In many other sectors, AI is actually a very intuitive thing for many people. For example, Google gives you the best answer to your questions. TikTok gives you the most interesting video to watch. Netflix suggests you your favorite movie. And cars, autopilot avoids obstacles, stops at traffic lights. Customer perception of the product is very binary and very intuitive and simple. But that's not the exact case with energy. So for energy storage, for example, what you see here is this is optimized decision spit out of our AI engine in a series of charge and discharge battery commands. How do you make sense of this time series graph as an average customer? So that's why I would say we really need to focus on the value proposition of your AI solution. It is super critical for both the buyer perspective and also the user perspective. For B2B buyers, a super sleek presentation or industry white paper is not enough for them to pay for an AI solution. You need to generate customer-specific insights and exact dollar values with their customer inputs. And for users, after the project's deployed, keeping them constantly informed about the value of AI-powered solution is also super important. At Tesla, I often run into some fire drills where like a customer facility manager wrote us a lengthy, angry email about why he thought this battery should behave A, B, C, and D. And they just have a preset mind of how batteries should charge and discharge and completely ignores the uncertainties in forecasts, changing site configurations, and all that. And I think it just makes no sense for that customer to spend time to decipher what this graph meant to them. So what we can do as AIPM, I think we should make values very explicitly to the customers by simulating through education and also simplification. So simulations with customer-specific inputs, I think needs to happen as early stage as the sales stage. That way, we build trust with customers and give them full understanding of how AI would have behaved with the specific conditions before even a project is deployed or contracted. So for B2B segments, simulations can be a very powerful tool because people are logical, customers are logical. Once you can present the value proposition in a very clear way, there are usually much less restrictions as long as pencils out. So for example, I was trying to persuade a existing customer to participate in our virtual power plant program. At first, they were very dubious about it. They know nothing about virtual power plant. So what we did is we took their data, modeled the potential outcomes using the exact machine learning algorithms deployed in the field. And we have a session with them and just talked through the values and benefits. And they were just, their eyes just light up and immediately sign up for the program. Because they know and fully understand the risk and benefits associated with it. So I would say another aspect of simulation kind of pertaining to AI product management is how do you scale this simulation functionality so that not just a couple machine learning engineers or you as a PM could run the simulations. So we really need to scale and democratize AI simulation functionality. So like it's just not, many people could do it. And it's really truly empowering to see everyone outside of the engineering org to run simulations and pitch benefits of AI to different customers. And secondly, is educate. We need to constantly educate our customers, providing documentations, overviews, white papers, FAQs, you name it, so that customer can learn more about our technology. And for sophisticated customers, we could also try different ways of exposing some of the mechanics of the algorithm, so they are more comfortable of how our products look ahead. And I would say education is important, but it's only important to a certain degree. I think the most powerful way to focus on your value proposition is just to simplify your product. So instead of having them stare at that obscure battery dispatch profile, just provide them savings report regularly, sending them all those paychecks by participating virtual power plants, selling them guarantees so they know that they can always earn money and have Tesla on the back, no matter what happens. And another elegant, simple solution that Tesla has deployed is Tesla Energy Plan. So you could think of it as a significantly discounted utility rate plan only eligible by Tesla customers. So customer would immediately know they would be charged less because they're buying our products. And in fact, Tesla Energy customers in Australia and in UK already kind of reaping the benefits of being part of this Tesla Energy Plan. They're saving over 30% on their utility energy bills. So to summarize, it's simulate, educate, and simplify. As AI PMs in the energy industry, our job is really just to make sure the products has clear, quantifiable value props, targeting the needs of each customer, and we can be able to kind of break down the value to the customer in a way they could easily understand. And lastly, let's take a breath and face the hard truth that AI is not a cure-all. Your customer might just not need it. For customers who have very intimate knowledge about their site behaviors, humans can actually do a lot better than predicting their energy consumption patterns than a machine. A classic example I would give is a particular commercial industrial customer I worked in the past in kind of the sport facility, and their facility is using a machinery that's kind of scheduled by appointment. So they know exactly when to turn on the machine and how much power it generate. So they understand perfectly what to do in that case to do demand charge management. So in that case, we are only providing AI as an optional secondary control layer. And also oftentimes, like, rule-based logic and manual processes may be inferior in terms of performance and maybe a little bit time-consuming, more labor-intensive, but it provides a lot of certainty. And people love certainty, especially in energy sector. And even though your AI solution is maybe a little bit superior, is that superiority justify the price premium? Not necessarily. And there's also another problem with energy sector is that there is just way too much stake to fully adopt AI. Unlike a easily discarded Netflix movie that you don't like, the wrong power system decision could actually cause catastrophic consequences, like a blackout across the system with huge economic impacts. So for big utility customers, they would never let someone to take control of their control room and their assets completely. They want to be informed by AI in decision making. They want to be augmented, but they want to make the call at the end of the day. So until AI could prove a step change in terms of reliability, safety, or financial upsides, a lot of energy customers will continue just rely on certain empirical solutions. AI is only nice to have. Kind of improving, augmenting their user experience. But I would say there's still some time for it to become the bread and butter of the energy industry. And lastly, I think we just need to keep in mind that AI is only part of the solution of addressing problems, and it's just a solution. We all know that the biggest mistake of any product manager is to be solution-minded. So sometimes customer may say they want AI, but in fact, they're just suggesting the solution they have no clue about. So as product managers, we need to dig deeper and fully understand the pain, their needs before jumping into gun and start showing your fancy AI solutions. I think at the end, I wanted to share a great quote from actually an energy software startup CEO. AI and machine learning shops are often just trying to look for the problems to solve rather than addressing the specific problems that utility face. All right, so this is my 4 lessons. Energy data is super messy. You gotta find your way around your customer and all your stakeholders. Really hone in on the value prop and understanding that AI is not a solution for everything. So lastly, I wanted to kind of talk about how to break into AI PM in the energy space. So first of all, I would say just try to get into energy industry. Focus on how to solve the needs for the customers, energy customers, instead of trying to look for that AI role. Although I stumbled into this kind of AI product management role at Tesla, I think I was kind of unique in my own situation. I would not recommend everybody specifically looking for that. My colleagues at Tesla energy product team come from all different backgrounds. They could be a sales engineer, a fleet manager, project financier, renewable developer, solar account manager, rate analyst. I actually wish I had experience in kind of a non-PM role before throwing into a product manager role. Because the market knowledge, the business context, and technical experience is really, really helpful for you to understand the problem space that your product can serve, and set you up success as a product manager later in your career. And the second piece is just owning your data like a boss. You might not have a PM title, but I would say before you become a PM, AI PM, you really need to really take ownership of data. Constantly ask yourself, how do I acquire this data? How much does it cost? What is the quality of the data? And how can we use this data set for? And another piece for kind of data ownership is that you don't need to have expert knowledge in AI ML, at least in some of the areas in energy, but you really need to be very familiar with statistic and basic analytical skills, and also very importantly, the grit to manipulate, play around the data, visualize large data set, and drive customer insights. And last piece, I would say, is just start small. Try to see if you can add a AI feature and component to your current work. It doesn't have to be any like deep learning reinforcement model, those fancy stuff you learn about. It could be just a good old linear regression. You could just start thinking about the data set, training your models, and measure the impacts you create for the customer. Going through that process is very effective to help you train your mindset as an AI PM in the energy industry. So that's all I have. My years at Tesla has been an incredible journey, and I am very honored to share with my learnings today. So let's together harness the power of AI to save our planet.